So for the solution of your quiz, yung problem solving, for problem number 1. So a consolidated undrained soil test was conducted on a normally consolidated sample with a chamber pressure of 140 kPa. So yung sigma 3 natin is 140 kPa. The sample failed when the deviator stress was 124 kPa. The pore water pressure in the sample at that time was 75 kPa. So which of the following gives the value of undrained angle of internal friction? Yung ating drain angle of internal friction, and of course, yung ating drain angle of internal friction if the soil possess a cohesion of 12 kPa. So we have here our solution. So given yung ating sigma 3, yung ating deviator stress, and of course, yung ating pore pressure. So ito yung ating normally consolidated undrained soil. Ito yung blue line, yan yung undrained soil natin. Yung red line, yan yung drained soil natin. So pag minus natin yung pore pressure, magkakaroon tayo ng drained soil. So yan yung ating effective. So to visualize our problem, we need to draw our figure para mas madali nating ma-solve yung problem natin. So, ito yung given, yung ating confining pressure. So, ito yung original, yung undrained, yung blue. So, ito yung confining pressure natin. Ito yung deviator stress natin. And, ito naman yung ating pore pressure. So, pag alam natin yung deviator stress natin, alam din natin itong radius natin dito, yung value dito sa failure natin, yung radius ng ating soil, which is equal to 62 kPa. The same with dun sa may drained soil natin. So, to complete our figure, lagay natin yung values ng pore pressure natin and then yung deviator stress natin. So, ano yung hinahanap natin? Yung internal friction sa may drain and undrained soil. So, ito yung internal friction sa may drain. Sa drain. Sa may, yung failure natin is andito sa ating drain. So, yung phi prime, yan yung internal friction natin sa drain. And yung phi is yung internal friction natin sa may undrained soil. So, to solve for our internal friction, syempre, kailangan muna natin kunin yung value natin ng ating maximum principal axis, yung effective principal axis natin, given yung ating minimum principal axis or yung tinatawag nating confining pressure, and our effective confining pressure or yung effective minimum principal axis natin. Yung notation natin dito sa ating effective minimum principal axis or yung effective confining pressure natin is sigma 3 prime. And dito naman sa ating effective maximum principal axis or major principal axis, that is sigma 1 prime. And of course, yung total natin, yung total maximum principal axis natin, which is denoted as our sigma 1. So, kailangan nating malaman yung values na yan para ma-solve natin itong angle of internal friction natin. So, first, ito yung hinahanap natin sa sigma 1, that is the maximum principal axis. So, para ma-solve natin ito, looking at the figure, from 0 to our chamber confining pressure, that is 140. So, just add our deviator stress, makukuha natin yung value sa ating sigma 1, which is equal to 264. Next is yung ating effective principal axis, major principal axis, yung ating sigma 1 prime. So, yung sigma 1 prime natin, andito yung sigma 1 prime natin. So, pag alam na natin itong sigma 1, looking at the figure, sigma 1 minus our pore pressure, yun na yung magiging effective major principal axis natin since aalisin natin yung effect ng water, yung pressure due to our water, yung pore pressure natin. That is equal to 189. So just subtract 75 sa 264. And of course, yung confining pressure natin, yung sigma 3 natin, which is given 140 kPa. And then yung effective, dito yung effective minor principal axis natin. So just have to subtract our pore pressure doon sa ating chamber confining pressure na 140. So 140 minus 75, that will result to 65. So yan na yung values natin sa 4 points na ito. So just have to write it here sa ating diagram. Ito yung 65, 140, 189, and 264. So looking at the figure, magkakaroon na tayo ng triangle. Ito yung isang triangle natin para makuha yung ating internal friction sa ating drained. And ito naman yung triangle na gagamitin natin to solve for the internal friction of our undrained soil. So first, solve for the undrained soil, yung phi natin. So we have here yung triangle. Ito yung triangle na yan. So yung R natin, 62, that is equal to 140 plus 62 since hanggang dito lang yung 140. And of course, yung andito sa gitna yung ating point nung ating radius. So yan, radius pa rin yan, that is 62. So 140 plus 62. Huwag kakalimutan that will have 90 degrees. Pati ito. Sa ating drawing, it's not scaled, so parang hindi siya na. So, using the SOHCAHTOA, yung sine natin, that is given kasi yung opposite and hypotenuse. So, sine of 62 over 140 plus 62 is 202. Makukuha na natin yung ating internal friction angle sa ating drain. So, paki-alis ito. Wala itong wala yung ating sine kasi sinine na natin. So, angle is equal to 17.87. So, yan yung sagot sa ating first question. So, for the second question, yung internal friction ng ating drain soil. So, sa drain soil, ito yung kukunin nating triangle sa may drain soil. So, kukunin natin yan. So, angle, that is 62. And then, of course, that is 65 plus yung radius na 62. Yan yung value natin dyan. So, using again the sine law, makukuha natin yung ating phi prime, yung ating internal angle sa ating drained soil. That is sine phi is equal to 62 over 127. That is 65 plus 62, 127. So, yung makukuha nating angle is 29.22 degrees. So, pakialis yung sine. Dapat walang sine yan. That is phi is equal to 29.22 degrees. So, that's the answer for our question number 2. So, for question number 1, yung angle natin is 17.87. And then, for the question number 2, yung sagot natin is 29.22. And for the third question, if we have a cohesion of 12, so, yan yung magiging figure natin. So, yung ating soil is normally consolidated, meron daw tayong cohesion na 12. To. So, drained angle of internal friction. So, kailangan lang natin kunin yung ating drained soil. So, ito yung drained soil natin. Ito yung sinolve natin kanina, yung 65 and then 62. Kaibahan lang dito, meron na tayong cohesion dito sa ating y-axis. So, meron na tayong 12. So, mag-a-adjust yung ating angle, yung ating failure plane. So, ito. So, looking at the figure, yan yung magiging triangle natin. So, yung gagawin natin dito, ito yung isang triangle natin, since hindi kasi natin alam ito. Pag nag-sin tayo, that is sin phi prime is equal to 62 over 127 plus x. Hindi natin alam yung value ng x. So, kailangan natin gumawa ng isa pang equation para magkaroon tayo ng two equations so that we can solve two unknown variable, which is the x and yung ating angle ng internal friction natin. So, kukunin natin yung isang equation dito sa triangle na ito. So, yan. So, looking at the triangle, makaka-create tayo ng equation. So, ito yung unang equation natin. So, tangent of our phi prime, that is equal to 12 over x. Yun yung unang equation natin. Yung pangalawang equation natin, itong triangle, that is sine of phi prime is equal to 62 over 127 plus x. So, two equation, two unknowns, we can solve for x and yung value ng ating internal drain friction angle. So, looking at our equation 1, phi prime is equal to the shift tangent of 12 over x. And then yung ating equation 2, phi prime is equal to shift sine of 62 over 127 plus x. So, solve these two equations simultaneously, makukuha natin yung value ng ating x, which is 27.36. And of course, yung ating internal friction angle sa ating drain soil na 23.63 degrees. So, ito yung magiging sagot natin sa question number 3. So, ito yung magiging sagot natin. 23.68 for problem number 1.